Hi, and welcome to another Brewha video. In this video we will be looking at how to set up the Brewha BIAC. While today we're setting up a 5-barrel BIAC, most of the features and fittings are also found on the smaller models. The first thing to set up is the hoist. On the larger models of the Brewha BIAC, an overhead hoist is necessary to raise the colander, and it makes dumping the grain out a very easy task. The hoist needs to be attached to something, and is particularly useful if that hoist can be on a trolley, so that when it is raised, the mash colander can be pushed over to the side where it can be lowered and easily dumped. The setup we are showing here can do precisely that. This is a 1-ton adjustable height gantry crane that can be purchased from Harbor Freight for about $800. One can also purchase a 1-ton trolley that can move back and forth on the I-beam at the top, and a 1,500-pound, 120-volt hoist that can be attached to the trolley by welding some brackets to a square tubing. All in, this gantry setup costs about $1,100 and it can be installed in about an hour. Now to set up the BIAC. Your BIAC will arrive in 2 wooden crates. The larger crate contains the 4-in-1 fermenter, and the smaller crate the mash colander. The crates open up by removing the screws holding the crate together. Once disassembled, the fermenter can be lifted with the overhead hoist and the stainless casters attached to the bottom. If your floor is particularly uneven, you may need to shim the caster plates to level out the fermenter, or if it is impractical to move the fermenter, the casters can be left off and the leg plate secured directly to the floor. With crates unpacked and the fermenter casters installed, we will start by assembling the fittings and valves. Each vessel has a bag with fittings in it for just that vessel, and a packing list inside each bag which describes where the fittings go. At the very bottom is installed, the very bottom of the fermenter is installed the 1 3/8 bottom dump valve. This is used to remove proteins after the boil and trub that has settled out during fermentation. A 90-degree hose barb can be installed in between the fermenter and the valve, or an elbow rather. However, wort should be circulated during the boil to ensure that it is properly sanitized, as the heat may not travel around the corner of the elbow down at the bottom. Beneath the valve, one can install the yeast harvester. This device can be installed late in fermentation to capture about 10 ounces or 300 milliliters of yeast that is settling out. It could be used multiple times to capture a larger amount of yeast. Close to the bottom port are 2 ferrules. One enters the jacket and is for chilling water. This is the port that the TCV attaches to. The other is for a bottom valve that can be used for racking beer to kegs or direct serving of beer to taps in your bar or restaurant once the trub has been removed and the bottom once the trub has been removed out of the bottom after fermentation and conditioning is complete. There are 2 1.5-inch ferrules remaining in the cone. One is for a valve for racking beer. The second ferrule is for the temperature probe. Either the probe is inserted directly, or if it's not a watertight probe, is placed inside a thermal well. There are 2 ports on the side of the tank. The lower is a tangential port that can be used either for installing a sample thief, or can be used for whirlpooling the wort to assist with chilling after the boil is complete. Cycling the boiling wort through the hose during the last 5 minutes of boil will heat sanitize the hoses and pumps. At the top of the side of the tank is the exit from the jacket. Never restrict the exit from the jacket in any way, as pressure could build up inside the jacket. Only an open hose, preferably a kink-resistant 3/4 inch or larger hose, should be used to ensure that water can leave the jacket as quickly as it enters, so the pressure does not build up inside. On the lid there are 2 smaller ports and 1 large diameter port. One of the smaller ports is for a blow-off hose, and later, once fermentation is complete, the gas-in valve for injecting CO2 to push the beer into kegs against gravity. The second small valve should be used for pressure and vacuum safety valve, or the smaller port, the second port. The large port is for inserting hops during fermentation. This port can also be used to insert a CIP system for for hands-free cleaning the tank. That completes the install of the fittings. Now to install the accessories. Starting at the bottom, there are 6 5,500 watt heating elements to install in the 5-barrel 4-in-1. There are 4 in the 3-barrel and 2 in the 1.5 barrel. The elements are 100% stainless steel, so they are no different than the walls of the vessel. They will not interact with the beer in any way. They are low watt density and will not scorch the wort. They come with short receptacles and are connected to the main power box with the 10-foot extension cords that are supplied. When not brewing, the extension cords can be removed so they don't present a tripping hazard. After each brew, they can be easily removed from the vessel. They should be inspected, the heating elements, and cleaned thoroughly, as sugars, yeast, or sediment left on the element could scorch in the next batch and add off flavor to the beer. On the lower jacket port, we install the water pressure regulator. This is an adjustable regulator that should be set to 7 psi on the heavier steel commercial tanks and 4 psi on the home brewing models. This regulator helps ensure that pressure does not climb too high in the jacket, damaging the vessel. The regulator can either be attached to the vessel or, more commonly, directly to the tap with the garden hose type fittings. The TCV, or temperature control valve, is a small solenoid that opens when powered to let chilling water in. It is connected to the water pressure regulator. If using chilling media other than tap water, the TCV might not need to be used, as a pump may be turned on instead of powering the TCV when needed. If higher flow volume is needed, for example for faster chilling of the wort in the 5-barrel system, a larger regulator can be installed on the main water supply line. The temperature sensor is connected to the ETC, or the electronic temperature controller. This device measures the temperature in the vessel and sends a signal to either heat or chill the vessel as needed. It can be used on the chilling side to power either the TCV or a chiller pump, and it can be used on the heating side to turn the PTC control box on or off, letting power through to the heating elements. The pump comes with a shorter, larger diameter intake hose and a smaller, longer exit hose. Its primary role is played during mashing, but it can also be used during heat up or chilling to help distribute the temperature throughout the vessel. For mashing, it is generally best to connect the pump inlet to the bottom port so that it can return grist that may have fallen through the mash colander and put it back up to the top of the grain bed. The pump also enables the most even circulation of wort throughout the grain bed, improving mash efficiency and ensuring a more even distribution of temperature. The pump return hose is connected to the port valve on the side of the mash colander. The valve is necessary to throttle pump flow so the pump doesn't remove wort from under the mash colander faster than it can be replaced, potentially exposing the element and damaging them. During chilling, I recommend withdrawing wort from the side racking port and returning the wort in through the tangential inlet, which allows heavier solids such as proteins to settle to the very bottom of the tank, where they can be withdrawn prior to aeration. As a caution, be sure to pump boiling wort for at least 5 minutes of the boil through the hose and pump in order to sanitize it, or you could introduce microbes into your wort during the chill. Off to the side, we have installed the Brewha PTC Power Box. The PTC Power Box is a simple, rugged, and dependable brewing controller in a watertight enclosure for splashdown environments like your brewery. With a watertight box and splash-proof fan air intake and exhaust, and liquid-tight cord grips, accidental overspray when cleaning will not damage your sensitive electronics. At the bottom of the box are 6 receptacles for plugging in the element extension cords, and there is a smaller 240-volt receptacle for the pump. The plug on the smaller power cord connects to the ETC that we have hung here on the wall. When the ETC senses that the wort is cooler than it should be, it sends a signal to the power box to let power through to the heating elements. We have kept the temperature controller separate, as this provides an easy means for controlling fermentation throughout multiple fermenters. You do not need multiple power boxes to monitor temperature in multiple fermenters. You just need multiple ETCs. The switch on the left side of the box is to turn the power controller and cooling fan on and off. The switch on the right controls the pump. The knob on the controller lets you select how much heat the elements will generate. At 100% output, with 240 volt, all 6 elements will produce 5,500 watts each. At 10% output, they will generate 550 watts, and so on. During fermentation, if using the power box to warm the fermenter, the output should be set at 2% or less, otherwise the elements could scorch the yeast and cause off flavors. The power box was intentionally built large to accommodate any additional electronics that you might want. For example, a touchscreen control interface, a PID controller, or a timer. They can all be easily integrated. The 3BBL box requires a 125 amp 240 single phase service, and the 5-barrel box requires 175 amp service. And that's it for the install. There are additional instructions on the Brewha website for use of additional accessories as well as care and maintenance of your Brewha equipment. Thank you for watching, and happy brewing.